Okay, and I'm back with another video. Today, I'm going to talk to you guys about how nuclear power works. So, without further ado, let's get started. So, what is nuclear power? Nuclear power is the use of nuclear reactions to produce steam that powers turbines, and those turbines convert that energy into electric energy, and that's where the power comes from. Some pictures right here of some nuclear generators. I'm going to talk about the components of these things and what these nuclear reactions are. So let's move on. So nuclear power mainly uses a process called nuclear fission, and then in some respects nuclear fusion. And it's mostly fission because fusion is used on very small scale, and there's still work on how to make this efficient. Let's talk about fission. Nuclear fission is a reaction that uses or takes advantage of the chain reaction effect. So it's a self-sustaining nuclear reaction. So let's zoom in and look at that. So what happens is you have a neutron, this neutrally charged subatomic particle that's it just spontaneously slams into uranium-235, which is an isotope of uranium. Isotopes are basically different versions of an element. So you can think of it like eggs. So eggs, you got fried eggs, you got poached eggs, scrambled, boiled. It's all eggs, but it's just different versions of eggs. It's just a very simple explainer. This version of uranium is very useful because once a neutron slams into it, it breaks up into some daughter molecules and releases neutrons. And those neutrons bang into other uranium-235s, and those break up into smaller pieces, and those other neutrons bang into other uranium-235s, and it just keeps going and going and going. And in the process, you're releasing heat or energy in the form of heat, and you are releasing photons, which is light. HV just means photons, okay? And this process just happens over and over and over, and it releases energy, and the energy turns water into steam. Steam powers turbines, and those turbines convert it into electric energy. And there's an electric generator in there, but we'll talk about that. Now we got nuclear fusion. Nuclear fusion is a reaction that happens, and what it is you have a couple small groups of subatomic particles. Here we have some protons and neutrons, and they slam into each other under intense pressure and heat, usually in the state of matter called plasma, which is just highly charged hot gas. And those groups of subatomic particles create a bigger group, but that bigger group breaks down into two smaller groups, and that releases energy. And that energy turns water into steam. Steam powers turbines. Turbines convert the energy into electric energy. Plasma is actually what lightning is. Lightning's just plasma, just a naturally occurring source of plasma. So the next time you see lightning, you'll remember, oh, that's plasma. Fusion is also how the sun is powered, right? A lot of the sun is plasma, and so under intense heat and pressure, you have these subatomic particles bouncing into each other, making bigger particles. Those particles break up, release energy, and that energy is in the form of heat, which is why we feel so much heat from the sun and why it gets so hot. The sun is a giant nuclear reactor, essentially. So nuclear power generators, they are usually found by sources of water because they need a lot of water. So the water comes up, goes through these tubes, goes into the system, nuclear reaction occurs, generates heat, right? That water turns to steam. That steam goes through this tube, which powers these turbines. And the steam that's not used comes back down, gets condensed in the water, and if not, it comes out the other end as non-radioactive steam. Once those turbines are powered, energy gets converted to electric energy, and that goes to power cities and other things. So that's essentially how it works in a very, very basic sense. So it's hard to not talk about nuclear weapons, so I'm just going to do a very brief overview of some of the nuclear weapons in history. There's no history lesson here, just going to talk about briefly how they work. The Hiroshima bomb takes an explosive that essentially shoots uranium-235 into some more uranium-235, reaching what's called a critical mass, basically when that chain reaction just happens over and over and over again on its own. And that itself creates a nuclear explosion. Both of these are fission reactions. Then you have Nagasaki, which takes a explosives that react with plutonium, causing a fission reaction, reaching critical mass, and thus exploding. That's a very, very basic explanation of how nuclear weapons, at least in this context, works. So some of the consequences of nuclear weapons, a lot of us are aware of these, but there's definitely extreme burns. At the immediate area, it gets incredibly hot to the point where anything in that area is immediately vaporized. There's nothing left. It's just gone. And then as far as human beings are concerned, there's radiation sickness that happens sometimes days to weeks. It can be delayed. It affects red blood cell count, which then proceeds to affect healing, physical healing. It damages DNA. It can cause all sorts of cancers. It's a very nasty technology when it comes to war. But nuclear power has, I think, a lot of benefits. There are pros, there are some cons, a lot of cons actually, and a lot of pros. So a couple things. It's pretty low cost. Once it's set up, it runs pretty well. There is zero carbon emissions, just the process. So that's a great sign when it comes to things like climate change. But with cons, there is a lot of environmental waste, and there is risk of nuclear accidents. And there's a lot more pros and cons. You can look those up, but I just wanted to give you some brief pros and cons. Nuclear power, I think, has a lot of future, and hopefully, as it gets more efficient, it will be used more often. So that's the end of the video. Again, it's just wanted to do a very short, brief video. Next up, we're going to probably finish our series. I will post a video on caffeine at the end of the week. And then we'll get into theophylline, the asthma medication. If you don't know what I'm talking about, you can watch the previous video. I do want to talk about male birth control. It's pretty trendy right now. And honestly, whatever I think of. I think these topics can go anywhere. And so if you have any suggestions, please feel free to comment them. And I just want to make interesting videos that people can enjoy and learn from. So thank you so much. I appreciate you listening and watching, and I will see you next time.